Namaste dosto, welcome to the channel. Today we're going on a deep dive into the fascinating world of electronics. You know how sometimes you look inside a gadget and it's just a mess of wires and shiny bits, and you're like, what kind of sorcery is this? Well, today we're cracking that code. We're breaking down the 15 most essential electrical components you'll find in just about every circuit. We're talking resistors, capacitors, diodes, the whole gang. We'll uncover what each one does, why it's important, and how they all work together to make the magic of electronics happen. So grab your safety goggles because things are about to get shockingly interesting. Let's get started. First up, we have the resistor, the unsung hero of many circuits. You can think of a resistor like a bouncer at a club. It controls the flow of partygoers, or in this case, electrical current, making sure things don't get too wild. Too much current can fry sensitive components, just like too many people can overwhelm a club. Resistors keep things cool by resisting some of that current, preventing damage and ensuring smooth operation. They come in different resistance values, measured in ohms. A higher ohm rating means more resistance, like a stricter bouncer. You'll find resistors in almost every electronic device, from your phone to your TV, doing the dirty work to keep things running smoothly. So next time you see a little resistor, give it a nod of appreciation for keeping those electrons in check. Next up is the diode, the one-way street of the electronics world. Imagine a one-way sign for electricity. That's essentially what a diode does. It allows current to flow in one direction, but blocks it in the other. This unique property is crucial for converting AC power, which constantly switches direction, to DC power, which flows in only one direction. Think of it like a traffic rectifier, ensuring all the cars are going the same way. Diodes are essential in power supplies, signal processing, and tons of other applications. They're like the traffic cops of your electronics, directing the flow of electricity and preventing any wrong-way crashes. So the next time you see a diode, remember, it's not just a two-faced component, it's the traffic director of the electrical world. Now let's talk about semiconductors, the real rock stars of modern electronics. These materials are like the moody teenagers of the electrical world. They're not quite conductors, not quite insulators, but somewhere in between. This unique property allows them to control the flow of electricity in really cool ways, making them the foundation for transistors, diodes, and integrated circuits, the brains of your computer. Semiconductors are like the Swiss Army knives of electronics, incredibly versatile and essential for everything from smartphones to spaceships. They've revolutionized the way we live, work, and play. So the next time you're using your smartphone or watching a movie on your 4K TV, remember that none of it would be possible without the magic of semiconductors. Next up is the capacitor, the energy squirrel of the electronics world. Imagine a tiny battery that can charge and discharge incredibly quickly. That's basically what a capacitor does. They store electrical energy and release it when needed, smoothing out voltage fluctuations and filtering signals. Think of them like the shock absorbers of your electronics, keeping things smooth and stable. Capacitors are crucial for everything from power supplies to audio equipment, ensuring a clean and consistent flow of energy. They're like the energy drinks of your electronics, providing that extra boost when needed. So, the next time you hear a clear and crisp sound from your headphones, thank a capacitor for keeping those audio signals smooth. Now let's talk about inductors, the masters of magnetism in the world of electronics. These components store energy in a magnetic field when electricity flows through them. Picture a coil of wire becoming a mini electromagnet, resisting changes in current. Inductors are like the stubborn mules of electronics, resisting any sudden changes in current flow. This property makes them incredibly useful for filtering out noise and unwanted frequencies in circuits. You'll find inductors in everything from power supplies to radio tuners, ensuring smooth operation and clear signals. They're like the noise-canceling headphones of electronics, blocking out unwanted interference. So the next time you tune your radio to your favorite station, thank an inductor for filtering out the noise and delivering that sweet, sweet sound. Now let's meet the transducer, the chameleon of the electronics world, a master of disguise in the world of energy. These components can convert one form of energy into another. Think of them as the interpreters between different energy languages. A microphone, for example, is a type of transducer that converts sound waves into electrical signals, allowing you to record your voice. A speaker does the opposite, converting electrical signals back into sound waves. Transducers are essential for interacting with the physical world, allowing us to hear, see, and feel. They're like the sensory organs of electronics, bridging the gap between the electrical and physical realms. So, the next time you listen to music, take a picture or feel the vibration of your phone, remember that it's all thanks to transducers, the energy shapeshifters of the electronics world. Chapter 7. Next up is the solenoid, the muscle of the electronics world. It's basically a coil of wire that acts like an electromagnet when you run current through it. Think of it like a tiny electric motor that can push or pull things with surprising force. Solenoids are used in all sorts of applications, from door locks and pinball machines to car starters and medical equipment. They're like the tiny but mighty workers of electronics, providing the mechanical force for countless tasks. So the next time you hear that satisfying clunk of a door lock engaging or the satisfying pop of a pinball machine, remember that it's likely a solenoid doing the heavy lifting. Chapter 8. Now let's talk about transformers, the voltage alchemists of the electronics world. These magical devices can change the voltage of an AC electrical current, either stepping it up or stepping it down, all without any direct electrical connection. Think of them like electrical gearboxes, allowing us to use electricity at different voltage levels for different purposes. For example, transformers are used to step down the high voltage from power lines to the lower voltage used in our homes. Transformers are essential for the efficient distribution and use of electricity. They're like the voltage regulators of the power grid, ensuring that electricity is delivered at the right voltage for every application. So, the next time you plug your phone charger into the wall, remember that a transformer is working behind the scenes to ensure that your phone gets the right voltage to charge safely. Chapter 9. Next up is the relay, the electric finger of the electronics world. It's an electrically controlled switch that allows a small electrical signal to control a much larger electrical current. Think of it like a light switch that can control a powerful motor. Relays are used in all sorts of applications, from controlling motors and lights to switching high-voltage circuits. They're like the electrical middlemen, allowing weak signals to control powerful forces. So the next time you turn on a light switch or start your car, remember that a relay might be working behind the scenes, acting as the electric finger that makes it all possible. Chapter 10. Contactor, the heavy-duty switch. Now let's meet the contactor, the big brother of the relay. It's basically a heavy-duty electrically controlled switch designed to handle much higher currents. Think of it like a relay on steroids, capable of switching hundreds or even thousands of amps. Contactors are essential for industrial applications where you need to control large motors, pumps, and other heavy equipment. They're like the power lifters of the electrical world, capable of handling the really heavy loads. So the next time you see a giant crane lifting a shipping container or a factory assembly line humming along, remember that contactors are likely playing a crucial role in controlling all that power. Chapter 11. Rectifier, the AC to DC converter. Now let's talk about rectifiers, the AC to DC superheroes of the electronics world. These components convert alternating current, which flows back and forth like the tide, into direct current, which flows in only one direction. Think of them like electrical one-way signs, ensuring that electricity flows in the right direction for electronic devices. Most electronic devices run on DC power, so rectifiers are essential for converting the AC power from our wall outlets into the DC power that our devices need. Rectifiers are found in just about every electronic device that plugs into the wall, from phone chargers to computers. They're like the unsung heroes of the power supply world, quietly converting AC to DC behind the scenes. So, the next time you plug in your phone to charge, remember that a rectifier is working hard to ensure that your phone gets the right kind of power. Chapter 12. Transistor, the electronic amplifier. Now let's meet the transistor, the star of the show in the world of electronics. These tiny components are the building blocks of modern electronics, used to amplify or switch electronic signals. Think of them like tiny electrical gates that can control the flow of electrons with incredible precision, allowing us to create everything from amplifiers and radios to computers and smartphones. Transistors have revolutionized the world of electronics, making it possible to create smaller, faster, and more powerful devices than ever before. They're the tiny brains behind our modern digital world, processing information and controlling the flow of electrons with incredible speed and accuracy. So, the next time you're using your smartphone, watching TV, or listening to music, remember that none of it would be possible without the magic of transistors. Now let's talk about inverters, the DC to AC wizards of the electronics world. These components do the opposite of what a rectifier does, converting direct current to alternating current. Think of them like electrical chameleons, changing the nature of electricity to suit our needs. Inverters are used in a variety of applications, from powering AC appliances from a DC source, like a battery, to grid-tie solar power systems. They're like the electrical translators, allowing us to use DC power sources with AC devices and vice versa. So, the next time you see a solar panel powering a home or an RV running appliances off a battery, remember that an inverter is likely working behind the scenes, converting DC to AC to make it all possible. Next up is the fuse, the superhero of circuit protection. It's a safety device designed to protect circuits from overcurrent, which can damage components or even start a fire. Think of it like a sacrificial lamb, designed to burn out and break the circuit if the current gets too high. Fuses are like the safety valves of the electrical world, preventing potentially dangerous situations by sacrificing themselves to protect the rest of the circuit. They come in various current ratings, ensuring that the right fuse is used for the specific circuit it's protecting. So, the next time you see a fuse, remember that it's not just a small and insignificant component, it's a crucial safety device that could save your electronics from a fiery demise. Finally, let's talk about voltage regulators, the guardians of stable voltage. These components ensure that a circuit receives a constant and stable voltage, even if the input voltage fluctuates or the load changes. Think of them like electrical noise filters, smoothing out any bumps or spikes in the voltage to provide a clean and stable supply. Voltage regulators are crucial for sensitive electronic components that require a specific voltage to operate correctly. They're like the voltage babysitters, always making sure that the voltage stays within the safe and acceptable range. So the next time you're using a sensitive electronic device, remember that a voltage regulator might be working quietly in the background, ensuring that it receives the clean and stable voltage it needs to function properly. Well, there you have it. That was a whirlwind tour of 15 essential electrical components. Hopefully you learned something new and maybe even gained a newfound appreciation for the intricate world of electronics. Remember, these components are the building blocks of everything from your smartphone to your car to the entire power grid. So, the next time you interact with an electronic device, take a moment to appreciate the amazing work of these tiny but mighty components. If you enjoyed this video, give it a big thumbs up, share it with your friends, and subscribe to the channel for more awesome content. And as always, let me know in the comments if you have any questions or if there's anything else you'd like to see me cover in a future video.